sure you like and subscribe before I go to the question. A and B plays a game where you win if you step all 12 floors upstairs. They take turns to roll a dice of 12 sides, which is number from 1 to 12 is written. If A roll a dice with a side of multiples of 4, A steps 4 floors. If B roll a dice with side of multiples of 6, B steps 6 floors. In other cases, they do not move. If A rolls the dice first, what will be the probability A will win? I'll go to the solution in 1, 2, 3. First, we will divide the possible cases of probability when A and B rolls the dice, which is divided into 4 cases. First, when A roll multiples of 6 or multiples of 4, and when A does not roll multiples of 4, and when B roll multiples of 4 and 6, and when B does not roll multiples of 6. Since there are 3 sizes of multiples of 4, 4, 8, 12, which is 3 sizes, and since the total size of the dices are 12 sides, the simplified probability will be 1 over 4. Then the probability when A does not roll multiple of 4 will be 3 over 4. It's the same logic. When B roll multiple of 6, the total size are 2 sizes, which is 6 and 12. The simplified probability will be 1 over 6. The probability when B does not roll multiple of 6 will be 5 over 6. This is the crucial first step for the question, and now let's get more deeper. You should have found out the 3 fundamental conditions for A to win the game. First, the last person to roll must be A, because this is a game that immediately finishes when someone steps 12 stairs. That means if B is the last person to roll in the game, that means the winner of the game is B, not A. So the last person to roll must be A. Second, A must roll multiples of 4 3 times, because the game, it says if A roll multiples of 4, he steps 4 floors. That means he needs 3 times to roll multiples of 4 in order to step 12 stairs. Lastly, B must no more roll the multiples of 6 more than 1, because in the description it says if B rolls multiples of 6, he is able to escalate 6 floors. Which means it only takes 2 turns of multiples of 6 to climb all the 12 stairs, which means B must not roll more than 1 in order for A to win. These are the 3 fundamental. For the next step, you should have found out there are infinite cases on how the game will flow. I'll explain that. The game might end really short, like this, but it might go longer, like this, might go even longer, like this, even more longer, like this, or the game might prolong for a very long time, very close to infinite, because there is a possibility that both A and B were not able to roll 4s and multiples of 4s and 6s, and that's the reason the game might prolong for infinitely long time. So that's the reason why there are infinite cases on how the game will end. So in order to solve this problem of infinite cases, the key concept to control this infinite cases and express it as an integer probability, you should come up with the concept of infinite series. We are going to use a mathematical expression using the infinite series. We'll divide the situation in 2 cases. The game where B never rolls multiples of 6, and the game where B rolls multiples of 6 one time. Let's start with the left situation first. In order to express the infinite into a mathematical expression, we will use the sigma notation. This K represents the number of rolls each A and B does, except for the last roll. Let me explain this in a diagram. This is simple. For example, A rolls, B rolls, A rolls, B rolls, A rolls, B rolls. It goes like that. And what the K represents is, except for the last row, among these 3 represents the number of K, And the number of these squares also represent the number of k. And the k must start at 2 because since a needs to roll three times the multiples of 4 in order to climb up all the 12 floors of the stairs. So this is the fastest game among the fastest game, which means the fastest game means the least amount of rolls needed to end the game. So a roll multiple of 6 at the first time, and next b rolls a rolls multiple and multiples of 4, sorry, and b rolls a rolls multiples of 4. Lastly, then except for the last roll, a rolls multiples of 4 and multiples of 4 2 times, and b rolls the dice 2 times. That's the reason why k must start at 2. Now let's erase this. And as I just mentioned, because a must roll multiples of 4 3 times, what we're gonna do is multiply 1 over 4 3 times. Let's draw a diagram. Sample diagram like this. Except for the last one. And the last one, the probability must be 1 over 4, as I mentioned in the 3 conditions for the A to win. We are going to choose 1 over 4, the two 1 over 4, among these K triangles, we are going to choose 2 among the K triangles to be the probability of 1 over 4. So, basically, choosing any two among the triangles is basically the combination of KC2. So we need to multiply the combination of KC2. If we have chosen like any one of the two triangles among the K triangles, for example, let's say I chose this and this, 4 over 1, 4 over 1. The rest of the remaining triangles are K minus 2. So basically, what we need to do is, since they are the ones that does not roll multiples of 4, the probability the K minus 2 triangle will have is 3 over 4. So what we are going to do is multiply 3 over 4 to the K minus 2 square. And finally, in this case, the B does not roll multiple of 6 even one time. So every single squares will have a probability of 5 over 6. That's the reason why we should multiply 5 over 6 to the kth power. Now we are finished with the case where B does not roll multiple of 6. Let's go for long. And before I go deep, both of this situation have the same number of triangles and the same condition to win same condition for A to win the game. So basically, the mathematical expression that I used for A, the 1 over 4, this, and this, will be also same in this situation. So we're gonna use the same mathematical expression we used for A in this case. We multiply 1 over 4 to the third square, multiply K combination 2 to E, and multiply 3 over 4 to K minus 2 power. And then the difference between the left situation and the right situation is that B roll multiple of 6 one time. So let's draw a diagram. So among these K squares, we are choosing one to have a multiple of 6, which means among these K square, it will contain a probability of 1 over 6. So what we do is multiply 1 over 6 and multiply K because any one of the K square can have the probability of 1 over 6. And lastly, if we chosen one square to have a probability of 1 over 6, then the rest of the K minus 1 square will have a probability of 5 over 6. So and finally, we multiply 5 over 6 to the K minus 1 power. Now we have finished